This is a continuation of a question we were doing in class on Module 6 for the HSC course on charged particles, conductors, electric and magnetic fields. The question involved two oppositely charged parallel electrically charged plates, one plus, one minus, separated by a distance of 0.5 meter. And you have an electron that's accelerating from the negative to the positive plate. In part A, you were asked to calculate the speed of the electron when it strikes the top plate, and that speed v was found to be around 5.93 times 10 to the 7 meters per second. Sanity check, it's quite a large speed because electrons are small, they have high velocity. And then part B asks you to graph a table of voltage and square velocity, where the voltage was the independent variable, so it goes on the x-axis. Remember I for I'm down here, the independent variable, and the square velocity, v squared, is the dependent variable. That's what's being measured, so that goes on the y-axis. So D for don't look down. So that's your graph for part B. It's worth 3 marks. So 1 mark for correct labeling of the axes, 1 mark for the data points, and 1 mark for the line of best fit. So it's a line of best fit. Remember, lines of best fit involve roughly the same number of data points above and below the line. If there's 3 above, 2 below, that's still fine. But if it's like 5 above the line, 2 below the line, that's not acceptable. So it's got to be roughly the same number of data points above and below the line. Okay, this graph here is a graph of voltage versus velocity squared. Okay, so that's your 3 marks there for the graph. Now part C asks us to estimate the charge on the particle, and that's 2 marks. They're not really easy marks to get. You have to sort of do a bit of thinking. So this is part C. Now let me talk you through this. How do we get charge? Well, we know that the electron's moving, so we need kinetic energy somehow. And we need to relate that somehow to the voltage, because it's moving through a potential difference. So what do we know about kinetic energy? We know that it's half mv squared. We know that for a charge Q moving in a potential difference V, there's work being done on it. So the formula involving the charge Q, the electron, and the voltage, potential difference, W equals QV. And we know from basic physics, hopefully, that work and kinetic energy are related by the following. So work is just changing kinetic energy, changing K. Okay, in other words, to do work on a system, you need to change the energy of the object. In this case, the kinetic energy. Okay, work is basically force at a distance. To get something moving, let's say, you need to change its energy somehow. It's kinetic energy in this case. Now, work is also equal to force times displacement, force times distance, in other words. Okay, just an FYI. So let's work with what we have. So half mv squared. Let's equate that to QV. Okay, there's a bit of thinking involved. It's not so much hard, it's just thinking through this. We know that V squared is 2Q over MV. Rearranging this here. But we also know from the graph, we can calculate the gradient of the line of best fit. Okay, gradient of the line, I'll tell you why. Gradient is rise over run. So select a few data points. Let me go with 5.25 minus 1.1 times that to the 10 to the power 6. 50 minus 10 times 10 to the 3. So the run, the x-axis numbers, this is the voltage in kilovolts. That's why it's 10 to the 3 to convert it into volts. The numerator here is the y-axis, the velocity squared. It's 10 to the 6. That's why I have that there. So I've chosen those data points. So with my data points, I'll get a gradient of this. So in other words, V squared over V is just 2Q over M. Okay, I calculated this just right here, that thing here. And that's equal to 2Q over M by rearranging this thing here. And so you can work out the charge of the electron quite simply from this, of the particle, I should say. Apologies, it's not an electron, it's another particle. Okay, from part A, it says the charge on another particle. So it's not an electron. Please disregard that. So 2Q on M, in other words, is 103.75. So Q is therefore this thing times the mass of the particle, which is actually given in the question. It's 1.5 times 10 to the minus 20 divided by 2. Do the calculation, you should get hopefully around 7.78 times 10 to the minus 19 coulombs. All right, give or take a few values here and there. If you get something around this, your answer will be correct. So that's how you solve this question.